This is the second half of the tutorial for Chapter 4, Section 3, Similar Figures, Part 3. And so let's take a look at this one again. And we've seen a problem similar to it, so let's see if we can do it again. Triangle ABC is similar to triangle DEF. That's what it's saying here. Find the value of x. So what we're going to do is write a proportion to do this. And so we're going to start off with BC. So side BC, and I'm going to write that as a ratio with side, let's go with AB. Now what I need to do is write a ratio of similar sides or corresponding sides. And so I'm looking at BC here. BC are the last 2 points in the statement for the triangle. So I need to use the last 2 points here. So EF are the ones that correspond to BC. If I look at AB, AB are the first 2. So the first 2 are DE. So those are the corresponding, that's the corresponding side in the other figure. So now I have that, I can go ahead and set up my problem. So I've got x minus 10 all over 70 would equal, and then I'd put EF, which is 35 over 65. So now I can go ahead and solve by cross multiplying. But before I do that, I'm going to take out a common factor and reduce these by 5, just make the problem a little bit easier on myself. So I've got now 7 over 13 equals x minus 10 all over 70. So now I'm ready to go ahead and solve. I'm going to do the cross multiplying. 70 times by 7 equals 13 times by x minus 10. So I can go ahead and distribute and multiply, and I got 490 equals 13x minus 1300, or 130 that is. And I can go ahead and add that 130 to both sides to cancel it out to isolate the x. So now I go ahead and add these, and I have 620 equals 13x. Well, when I go ahead and try to do the division, I see 13 doesn't quite go in there evenly, so I end up with a decimal. And I'm going to go ahead and just estimate this, approximated here, to the nearest hundredth, and I'm going to call it 47.69. And that would be my answer. Now the next one, they ask, while playing tennis, Matt is 12 meters from the net. So this is the net right here. He's 12 meters from the net. And he wants to hit the ball so that it just clears the net and lands 6 meters beyond the net. So that's where he wants it to land. So he's going to hit it from this point here, and it's going to carry all the way over the net and then down to this point. So he's gone a total of 18 meters. So if I add 6 and 12, I'm getting 18 meters. And we're going to need that number when we're doing this work. So 18 meters is the total distance he's going to want to hit the ball prior to it landing on the ground. So now what we want to do is we want to find out how high up he must hit the ball. How high in the air must the ball end up being? And that's what this H stands for right here. So what we're going to do is come up with a similar triangle. See, we've got this one triangle, and it is 6 meters by 0.9. And then we've got another triangle that's similar, and the reason why it's similar is because they have some angles in common. See, they both have a 90-degree angle here, 90-degree angle, and they share this angle right here. We don't know what it is, but we know it's the same angle because, see, it's the same angle. It's this angle right here. BAC is the same as DAE. So I know these are similar triangles due to the angle-angle postulate. And so now I can go ahead and use an idea about proportions to solve for a missing side. So the length from A to D, so from A to D here is 12, or not 12, but 18 meters, because I added these two numbers together, the 6 and the 12 together to make a total of 18. And I know this side's H. So let's go ahead and set up our problem. 0.9 is to 6. Now since 0.9 and H are corresponding, they're both the height of the net and height of how high Matt needs to hit the ball to make it clear. And that's why they're both on top of the fraction. That's just the way I had it set up. So now I go ahead and cross multiply. So 18 times by 0.9. And I'm going to set that equal to 6 times by H. So go ahead and multiply 9/10 of 18 is going to give me something just a little smaller than 18. It's going to be 16.2 equals 6H. And then when I go ahead and divide by the 6, I end up with 2.7 meters is what H is. So now I just need to state a little sentence about what happened here and what that answer represents. And so we could say Matt should hit the ball 2.7 meters from the ground to clear the net. So he needs to hit it 2.7 meters from the ground to clear the net. So those are the types of problems you're going to end up seeing on tonight's homework. Good luck.